Hello, and welcome to episode 76 of Public Interest Podcast with your host, Jordan Cooper, where we interview politicians, activists, advocates, and others who seek to improve the state of the world. We are here today with Dr. Noel Rose, who's known as the father of autoimmunity. He has a long list of titles that I'm about to go through. He is the Professor Emeritus of Johns Hopkins Bloomberg School of Public Health and Johns Hopkins School of Medicine, a senior lecturer of pathology at Harvard Medical School, nominated for the Nobel Prize in Medicine, founding director of the Center on Autoimmune Disease at the Johns Hopkins Bloomberg School of Public Health, the director of the Autoimmune Disorders Center at the World Health Organization and Pan American Health Organization. Dr. Noel Rose, thank you so much for joining us. How are you doing today?
Doing very well, thank you.
Excellent. The first question I'd like to pose to you is, what are you currently doing, or what have you ever done to advance the public interest, and why?
Well, let me separate that into the two components. First of all, what I'm now doing is perhaps best described as a retirement job. I have been an active research physician for 60 years. That is, a physician who essentially directs a research laboratory studying, in my case, autoimmunity and autoimmune disease. And having now reached an age when I think it's better to turn that laboratory over to younger colleagues, I moved my wife and myself to a new abode in Boston, Massachusetts, and I have a part-time position teaching, mentoring, and assisting in any way I can at Harvard Medical School. And so what I'm now doing is to spend time when I would formerly be actively directing a research laboratory. I'm working with other people doing research. I'm working with students who are going to be physicians or scientists of the future.
So it sounds like you've played three roles in your life, primarily from a professional perspective: being a physician, being a researcher, and being an instructor, a professor. How is that a fair assessment of the different primary categories you've held in your professional life?
I think that's probably very accurate, yes.
So in reflecting on, let's take them one by one. So you're a physician, a researcher, and an instructor. Why is it, what first attracted you to the field of medicine? Why did you ever decide to be a physician? And what challenges did you have in applying? I know you went to Yale Medical School, and as a Jewish student, there were quotas when you went to medical school. And can you talk a little bit about the challenges as well as your initial interest in going to medical school?
Yes. Well, okay. We have, as you said, three different components: teaching, doing research, and being involved in medicine and medical practice. And in reality, it's all one. And so what I do really is discovery. So I've always been very curious about why things are what they are. Why do things happen as they happen? Why are things as they appear to us? And that's related to both human endeavors and to nature more broadly. So I knew from a very early age, in fact, 7th grade, that I wanted to be a scientist. I wanted to be an investigator. I wanted to discover things that nobody had ever known before. And in a sense, that has been a guiding principle of mine all through my life. So my great satisfactions outside of my personal life with my own family have really been to discover new things that no one else had ever seen. I chose the field of medicine because there I felt I could have a great deal of impact. My father was a practicing physician, and I greatly admired him, and I'm sure that he was responsible for improving many lives and saving many lives.
Mm-hmm.
But as an investigator, I soon realized that if you can make an important biological discovery, you can save not just tens and hundreds of people, but thousands of people. So it was clear that if I'm going into medicine, the kind of medicine I'd like to be involved in is not the hands-on practice of medicine, much as I admire that, but rather the creation of new knowledge and new understanding that would further the entire field of medicine and would have impact broadly on the public and on humanity. So it satisfied my desire not only for discovery, but my desire to help people in all parts of the world by discovering new knowledge.
I'd like to talk a little bit about discovery, and you. What is it about you that allows you to see things no one else has ever seen before, yet has always been within us, literally, in our own bodies or right before our eyes? What is it about you that has allowed you to make discoveries? Why have you seen things that so many people have passed by before without ever noticing?
Yeah, I think it's because I've always had an innate curiosity. I've always wondered why things are as they are. So we very often accept things. Oh, well, this is just what it is. This is just the way it works. And I was somehow or other, I'm not saying endowed or handicapped, I'm not sure which, is saying, well, that's maybe so, but why is that so? And what are the alternatives? And so it's the ability of looking at things a little more deeply, with a little more curiosity, even, I might say, a little more skepticism than other people.
Has that made your life more difficult in any way?
It makes for a very restless life, and I think one of the characteristics that come from that is a desire to be moving on all the time, to move into new fields and to new areas of research. And so while my research has followed a pathway, that is understanding autoimmune disease broadly, it's taken on many, many different forms and many different aspects, and I've been very fortunate in being able to move from one field to another and to remain at the forefront of research because I've been driven by a desire to discover new things and not to plow ground that has already been plowed before me.
I've found often in society that though you are not involved in electoral politics, you have been a professor at a university in which it can almost be an understatement to say that there are politics in universities, in many workplaces. And I wonder if you have a perspective driven, as you say, by innate curiosity, where you don't accept things as they are and ask, why is it so? And can it be different? That may have created friction in some way. Did you ever have any difficulties reconciling your perspective and approach to being a welcome member among your colleagues in academia?
Well, that's an interesting question. I guess I've been unusually fortunate from that point of view. I think your premise is correct. A university is a human institution. The human beings are, by nature, sometimes contentious, and we see that at universities. And universities also tend to be somewhat, I'm trying to think of a good, gentle word for it, but the orderly organization. So there are rules. And sometimes I've been, I thought, retarded by rules. And I've been extraordinarily fortunate from that point of view because I was able to make some major biomedical discoveries very early in my career, and that gave me, I would have to say, a certain amount of privilege within the university. So I've been able to ask for and receive things that are a little out of the ordinary, that most faculty members don't enjoy. And so I've had a career that has been much more flexible, much more plastic than most faculty members who've followed a more standard academic pathway.
Did it ever elicit jealousy in your colleagues that, for instance, hypothetically, there might have been a professor who was 50 years old and had been toiling away for decades in his lab, and then you came along, and I think in your 20s, well, it was in 1955, I think, that you really came out with your big discovery in autoimmune disease. You might have been much younger than him. Do you think there have ever been jealousies that you've elicited because of your success, and did that ever impact your work in the ivory tower?
Well, the answer is I guess I don't know. It has never encumbered my progress at all.
All right. Well, good.
I've always been, I think, very well accepted by my colleagues. I've been an elected faculty member in the university senate, the faculty assembly. I've received many honors from fellow faculty members representing them. So I don't think it's been a major problem.
Wonderful. So let's get into autoimmune disease. Why are you the father of autoimmune disease? How did you even discover it, and why were you interested in it?
Well, I'll tell you that story. It's an interesting one and really represents the fact that most of us get into a research which is not what we had intended originally. So I was then a medical student, but also doing research. I was able to start research very early, and I worked with a very noted immunologist named Witebsky, who was interested in the antigens. Those are the molecules that mark certain cells, that tell us which cells are which and from whom they're derived. He was interested in those kinds of antigens of cell molecules, and in many different roles, but particularly interested in the antigens that distinguish normal cells from cancer cells. So he wanted me to look into some of the differences in the gland in the neck called the thyroid gland, and that led to a series of investigations. And as part of them, I found that these molecules within the thyroid gland of a person or of an animal normally don't excite an immune response, as you would expect. You don't think somebody's own molecules, own antigens are going to create an immune response. And I found, much to my surprise and much against the dogma of the day, that in fact it can be done if you do it in the proper way. And so then I began to think, well, if that happens, what is the outcome? Suppose you do develop an immune response to something in your own body. What would be the consequence of that? And it seemed to me the consequence would be illness, would be disease. And that would be disease that's due to autoimmunity, immunity to self. And so that's when the concept of autoimmune disease came about. I have to say that idea had been in the literature, in the scientific literature, half a century ago, in the 1900s. Some people speculated about this and even did some experiments to find that it's true, but they weren't done in the way that we were able to do them in 1950, and they never really did develop the evidence for it. And the idea was not only not accepted, it was derided. People thought it was probably foolish. But I think we were able to amass the evidence to show that it's true, and not only true, but relatively common, that many diseases the cause of which we didn't know are really due to this misdirected autoimmune response.
So in studying cancer, you ended up accidentally resurrecting a previously rebuffed concept.
Exactly.
And you ran with it. So you found, to your surprise, that something that not only had been seen before, but people had been living with autoimmune disease for as long as people had been around, and yet you were the first one to really be able to build up evidence for it. So proceed. So how did your career, so once you were able to name that autoimmune disease actually existed, and you were able to defend that and present the evidence, then what happened?
Well, as some often happens in medicine, this idea we published and other people published. Our results were rapidly confirmed and done in other laboratories and other clinics. Then, in a way, the race was on. People thought, well, if autoimmune disease can essentially destroy the function of the thyroid gland, then maybe autoimmunity can cause other diseases. And so there was great attention to diseases that were very highly prevalent, like lupus or like type 1 diabetes or like multiple sclerosis or myasthenia gravis or scleroderma, on and on and on. Many diseases came along one after another. And so,
how many diseases are there?
Well, it depends a little on how you define an autoimmune disease. Most, let's say the NIH usually recognizes somewhere between 80 and 100 as human diseases in which autoimmunity is a cause or is a major contributor.
And before you ever came up with your research, were these 100 diseases known but thought to be something else and they didn't know why it happened? Or did you basically discover whole new diseases?
No, the diseases all were known. Not all, but most of them were well known. Some of them were very well known. Rheumatoid arthritis was a very common disease, and people just didn't know why they occurred. So they might have developed ways of treating the disease, but they really didn't know what the cause was.
And what proportion of the American or the global population is afflicted with an autoimmune disease of some kind?
Well, now the best figures are that something like 20 million Americans have an autoimmune disease. So the figures are somewhere between 14 million and 23 million. So I would say somewhere in the $20 million neighborhood is a pretty conservative estimate of the number of people in the United States right at this moment who have an autoimmune disease.
So out of 300 million or so Americans, that's about like 8% of the American population?
That's just about right, yeah.
So almost 1 in 10 Americans has some kind of autoimmune disease. So now that we've identified the cause of these diseases and that people have them, and we've classified them into a new classification category, how do we solve them? Were you ever able to identify treatments or potentially even cures for an autoimmune disease?
Well, the answer is yes. Not me personally. I haven't developed a treatment for an autoimmune disease with my own hands, but we've provided the basic science on which treatments have been developed. So autoimmune diseases, which when I started were very often fatal, now people can be treated successfully and live often a normal lifespan and normal lifestyle. So a disease like lupus, when I was in medical school, was considered a fatal disease. Most people who were diagnosed with lupus were expected to die within 5 years. Now, with good care, most lupus patients can live a full and relatively normal life. So treatment has improved enormously over the the decades I've been in research.
And to what extent would you say that your discoveries have contributed to those treatments, that some of that lives have been saved as a direct result of your efforts, or an indirect result of your efforts?
I would say indirect, but I can only say if there are 20 million people with autoimmune disease, and most of those people have much better lives today than they did when I started 60 years ago. It must be many millions of people have been the indirect
recipients, beneficiaries.
Indirectly, let's say, from the basic science that we carried out in our laboratory.
So you originally, you were in medical school, you saw your dad practicing as a physician, and you said, well, I could save lives dozens or hundreds at a time like my father, or I can save lives millions at a time, or at least thousands or hundreds of thousands, and now today millions at a time, if I were to go into research. And then lo and behold, you actually were able to execute and dedicate your whole life really demonstrably benefiting and saving millions of lives. Please reflect on that. What does that say to you about your life and that you really attained your goal?
Well, it's certainly that's the biggest reward we get from doing this work. Research may sound very glamorous, but most of research is negative. People don't understand that. But in research, we are usually working, it's perhaps a little hard to say, to disprove things. That is, we develop a hypothesis. We think this might be the reason that something's happening. And then we work very hard to disprove that hypothesis. We just try everything we can to say, well, my answer is the wrong answer. And we may spend years doing that. And then finally, when we've just answered every question that we've raised or that our colleagues have raised, and nobody has found any other explanation, then we can say, all right, this is probably within the bounds of our knowledge at this point in time. This is probably the best answer. So that's
just kind of like, somewhat like Thomas Edison saying, I tried to find 1,000 or 2,000 filaments for a light bulb that didn't work, and then I found 2,000 ways not to make a light bulb filament. So it sounds like a lot of research is you trying to find. You spend a lot of time trying to find the right thing, and the vast majority of your time you're not actually finding, just making any discovery.
That's exactly right.
So how do you remain persistent throughout a career that is, how many more discoveries were you able to make after that original discovery? Did you keep making discoveries throughout your life? Well,
life is really some big discoveries, and I've been fortunate enough to make maybe 2 or 3 really big ones, and then hundreds of little ones. It's the big ones, obviously, you'd like to make. You'd like to discover something that's completely new, and that has so many rewards in terms of your own satisfaction and your satisfaction in knowing that this probably is going to benefit many other people and advance the march of science.
And yet you also have been a professor. You've been teaching students. So it hasn't been enough just to make discoveries and saving lives through your research, but you've also tried to create future researchers so that others can build upon your discoveries. Can you talk a little bit about what your approach to education has been?
Well, I'm glad you brought that up again, because when we started, you were mentioning, perhaps 3 different things that I do. One is a teacher, and one is an investigator, and one is a physician, and I've said they're really all the same. And in many ways, that's why I've enjoyed being a professor at a university, particularly a very good university where we have excellent students, because that keeps you going all the time. Even between discoveries, and as I say, discoveries aren't things that happen every day. You have another satisfaction, and that is you work with young people and you teach, you share your knowledge and your understanding with young people, and you see them grow and you see their careers develop, and you're contributing that way every single day. And as a physician also, you see your work. Most of us have retained some clinical activities along the way, so that we get satisfaction from our physician activities also. So it isn't, in my own view, it's much more satisfying to be doing all three things than only one. Although many people prefer just to do research or just to practice clinical medicine or to teach only. I've been very fortunate in being able to do all three all my life.
And so you have sustained yourself through the doldrums of research failure, where you are proving things wrong or not making discoveries. You've sustained yourself through that period by the joys of teaching, which you say you find quite rewarding, and then that kept you buoyant while you were doing research that, in particular periods of your life, may not have borne much fruit. Is that correct? You've been very passionate with your teaching?
Yeah, that's a very good way of doing it. So when you're a teacher, you have other satisfactions during the down periods in research, when things in the lab are just not going well. You have other things that are keeping your spirits high.
And you actually went above and beyond, reaching out not only to students within your field in medicine, but you, at the School of Public Health, you also started an introduction to biomedical sciences for individuals who had never had basic anatomy and physiology before. Why is that, and how did you get started with that, and how was that different?
Well, that's, again, something I've loved very much, and it is something I have derived a lot of satisfaction from. So, briefly, in the School of Public Health, many people are coming into the field of public health. It's a very active, very vibrant field, and people are coming in with different kinds of skills. So they're not just physicians and nurses and dentists and veterinarians, as it might have been 50 years ago, but it's lawyers and sociologists and mathematicians and engineers and just
dare I say a politician?
And right, even young politicians. And they need to be able to speak the language. They need to be able to communicate with people doing medically related research, public health research. They need to have enough of an understanding of how the body works and why disease occurs, at least as far as we understand it. And how do we do that? Well, the history is a long one, but when I retired as department chairman, which I did when I was 65, I had an opportunity to take over a course which was designed along these ways. We transformed it quite a bit into I think a much more active course, and one that frankly turned out to be a lot of fun. And we took quite a large number of students and put them through a series of exercises that were educational on one hand, but I think really enjoyable. And they learned in 2 solid weeks of total immersion teaching just an enormous amount of how the body actually operates.
Well, as a former student in that class of yours, I can attest to the veracity of your statement. So we're coming up upon the end of the podcast, Dr. Rose, and gosh, you have been nominated for a Nobel Prize. You have saved dozens of millions of lives. You've inspired students for generations. to make new discoveries and to perpetuate the mission of saving lives through their own efforts in many fields across society. You've always pursued a career of discovery in order to advance the public interest. Why have you done all this? What has driven you through disappointments, or through how have you managed to be so successful, to have accomplished so much in your life? You really have left your mark on the world and in science. How have you managed to do it?
Well, I have been very fortunate. I sometimes say that I'm a member of the real 1%, because I think the people who are very fortunate are not necessarily the wealthiest people in our society, but those of us who have been fortunate enough to find a career in a work that we love. So for me, it's been exciting every day. Every day it's been new. Every day I learn something, even if it's just to prove something is wrong, or just to teach a class and find it's not going well, but I've learned something from that experience. So it's been a real privilege to have a life and a career in which we really have derived the greatest enjoyment ourselves. And so I think I would wish everybody in your audience the good fortune I've had to find a life and a career of something that you really enjoy and you really would do even if you didn't depend on it to make a living.
That's Dr. Noel Rose, the father of autoimmunity, who measures wealth not in terms of dollars and cents or a number in your bank account, but Dr. Rose measures wealth by the ability to spend your life doing what you love, challenging preconceptions, indulging your intellectual curiosity, inspiring generations of new students, and engaging with material that enables you to learn something new every day. That is public service, advancing the public interest through your own passion and allowing it to be contagious so that others can indulge their passions and in their own way seek to improve the world. That is how Dr. Noel Rose has spent his life advancing the public interest. Dr. Rose, thank you so much for joining us today.
Thank you for the privilege.
This has been episode 76 of Public Interest Podcast with your host, Jordan Cooper, where we interview politicians, activists, advocates, and others who seek to improve the state of the world. We thank you for joining us. We'll talk to you next time.